So what do Roman numerals, F#, C#, Visual Studio 2019 on Windows, Visual Studio Code on Mac all have in common? Check it out with F# testing. Hello and welcome to another episode of On.net. My name is Jeremy Lickness and I'm here with Phillip Carter and his broken arm to talk about F# testing. Before we get started, Phillip, tell us a little bit about what you do at Microsoft.
Well, aside from appearing on camera with sort of like stormtrooper garb as a result of shattering one's arm, I work on F# and the F# tools at Microsoft on the greater .NET team, which F# is a part of. And I'm actually pretty excited because we fairly recently released F# 4.6, and an update to the F# tools in Visual Studio 2019 just came out. So I'm pretty excited.
So lots of great updates rolling out, but what we're going to look at today, I understand, is testing, and not just testing in the traditional Visual Studio that a lot of people are familiar with, but also cross-platform testing, looking at Visual Studio Code as well.
Yeah, absolutely. So just to give a little bit of an overview, there's like a plethora of ways that you can test in F#. Like you can just do this for days. So I can only cover like a really tiny subset. So first, I just want to kind of show the things that you can do in VS 2019. Just kind of briefly, like we have some project templates. They sort of do kind of what you would expect to do if you're a C# developer and you're interested in getting into F#, especially from a testing perspective. Then I want to move over to Visual Studio Code and the .NET CLI and get into slightly more advanced testing. And I want to show off this really cool library called FSCheck, which is a property-based testing library. I'll kind of explain what that means as we're sort of looking through the code. But what's really neat is it's this F# library that sort of grew within the F# community, and it was sort of made in F# for F# and then expanded out further, and now it's just a really great .NET library used by a lot of C# programmers as well. So it's this cool thing that was this F# community treasure that was able to really flourish. So
that's what we love about .NET, right? We can pick one of our favorite languages or even mix and match. I've seen projects with multiple languages, so
absolutely,
that's cool. So we're going to start off with Visual Studio 2019.
Yeah. So basically, the way that I like to think about it is sort of your entry point of how you're going to do tests. Is do you prefer Visual Studio or do you prefer working with command line stuff? If you prefer Visual Studio and you're on Windows, go ahead and use VS 2019. It's got everything you need in the box. You just click download link and everything's there. You have like basically zero setup involved. You just have to actually install it. And if you prefer the command line, you can just go ahead and download .NET Core. And then if you have Visual Studio Code and Ionide, which I personally prefer, Ionide's a plugin that you can install in Visual Studio Code. It's got like 1.2 million downloads or something like that. It's pretty easy to find. Then you can have a good command line tool set, and you can just new up a bunch of really cool stuff, and you get a great editor with VS Code and Ionide. So
very cool. Looking forward to seeing that.
Yeah. So let's hop over to Visual Studio 2019. So I've got the new project dialog here. So first thing that everybody does there, you create a new project. I'm going to select F# from the language dropdown. And there's quite a few templates, so I scroll to the bottom. I'm going to go with an XUnit test project.
Now, are all these templates out of the box with a 2019 install as long as I have F# available? Okay.
Yeah,
great.
Basically, it's actually really hard to not get F# in Visual Studio.
Okay.
Because it's part of the .NET Core SDK.
Right.
So the .NET SDK comes with all sorts of different, if you want to do any kind of web programming, if you want to do desktop programming, it's just sort of there by default.
So it's part of those workloads that built in. Okay.
Yeah, and so once you get that, you get all these F# templates lighting up. So I'm going to go with XUnit. You could go with MSTest. You could go with NUnit. But I'm going to use XUnit for this one. Let's just call this demo because I'm not very creative with names. So we're going to create the project. It's going to initialize some stuff, load up Visual Studio.
You took it one step further than I do it. I usually take the default name, so at least naming it demo is more creative.
There's, I think it needs to resolve NuGet packages here. Yeah, so that's going to take it. So it needs to resolve all the dependencies, and then it also needs to resolve the test runner dependencies. So there's a bit more to it than just some regular code. But so it gives you a new test here. There's this feature in F# that lets you sort of just use extremely descriptive names, like you don't have to do this Pascal case or snake case or something like that.
You can just call the test what it is.
Yeah,
basically.
exactly. So this is called my test. And this just asserts that true is true. So I can just go ahead and run this in the Test Explorer. It's going to have to build the project. I believe it needs to restore package. It may have done that in the package cache. Hard to say. OK, it's already running the test. And this passed just as you would expect. So you can see all the little icons, sort of things are grouped the way that things are normally grouped in C#. Does the exact same thing in F#. So if I just wanted to get this thing to fail, I'm going to assert that false is true, which is obviously not going to work.
Right. We hope this doesn't pass, or there's something terribly wrong.
That'd be a serious bug. I would not be happy. OK,
Yeah.
it failed. We're all happy. False is not true. You can do all sorts of interesting stuff here. Like I could just write some normal F# code. I could have like a library, and the way that you do unit testing in C#, you have your library, and then you have your unit test project. You reference the library. You want to hold some invariants and go ahead and test those. And
so it's basically we're using a different language, but same approach, methodology, and exact same test runner.
Exactly. Yeah, and the reason it's all .NET. The test runner just says, "Hey, I speak .NET." So when this thing gets compiled, it gets compiled down into a binary, just regular IL. This thing reads the IL, it identifies where the test is, and then voila, everything's there.
Great.
Yeah. But rather than stay in Visual Studio, I want to go over to Visual Studio Code and the .NET CLI, kind of as I mentioned there.
Okay.
Because I have something a bit more advanced set up, and it's pretty neat. So I'll show you that. So what I have here is Visual Studio Code. I have a theme plugin here, so it looks slightly different than you would normally get.
Dark themes are the way to go, though. So.
Exactly. That's what's hip these days. Eventually, it's going to go back to light themes, I think.
You think so?
I don't know.
A lot of people love their dark themes.
Yeah, yeah. So you'll notice a few things here that might be a little bit different if you've installed Visual Studio Code without F#. So if I go over to the Extensions tab, there's a whole bunch of stuff here, but I have installed Ionide F# here. So this has 1.2 million downloads. This is sort of the official F# plugin for Visual Studio Code. It gives you basically a fully fledged IDE experience. You get all the IntelliSense that you would normally get with a Visual Studio, modulo a few differences, like it does a few things more than VS, VS does a few things more than it, but sort of the core experiences are all there.
Okay.
But the main difference is rather than sort of being like this, everything is all just little buttons that you click and sort of, everything is all lined up the way that you want it to be. Visual Studio Code and Ionide are more for the kinds of people who like to sort of wire things up themselves. They like to use command line interfaces. They like to, just be, I guess you could classify it as like being a bit more free with the way that they do things, right? Right. It's sort of like library versus framework sort of thing.
Sure.
Like using F# within Visual Studio is like a framework. There's sort of like a lot of very prescribed ways to do things, and when you do it that way, it's great. But if you're like, oh, I want to compose this little piece with this other little piece, but I don't want these things in a solution file or something. Well, so it's a bit harder to do in Visual Studio, but you can easily do that in Visual Studio Code if that's your thing.
So I find that a lot of C# developers, I think because they grew up with Visual Studio, prefer Visual Studio over the command line. Yeah. Are you finding that with F# there's a preference, or is it pretty much split down the middle?
I'd say it's fairly split down the middle. When we look at our users, there's definitely there are people who they don't run on Windows. They use a Mac. They use Linux machines. They use VS Code. They use a command line. Sometimes they don't even use VS Code. They'll use just their own editor.
Okay.
And they're like, I want to set up everything myself.
Right.
And then we have the other group who are like, I want to be in Visual Studio. I want sort of like a first class experience with these certain tailored things, and I want to work in that framework. So it's good to have that variety. So figured I'd bring it up. So back to this testing thing, I have the Ionide plugin installed, and over on the left, there's this little F# tab. And this is sort of like a solution view. Okay. So I actually have a solution, and I have a library that I've named Roman numerals. And then I have a test project here called Roman numerals test. So in the Roman numerals library, it's super naive, basic stuff, but it can be used to demonstrate a few cool things. Basically, it just takes in an int and converts it into sort of an equivalent Roman numeral string. You could This is basically
So it's
always gonna be
basically
wrong,
turning
yeah.
into I's, breaking I's down into V's, V's down into.
In a way, yeah.
Yeah.
I mean, like this is not, and like a library that does that for real is actually a bit more complicated,
Sure.
especially if you consider the different dialects of Roman numerals. Uh,
Right.
But I didn't want to get into that. So, anyways, this is basically all it does, and there's sort of like this little private function here, and then I have the main function here that just sort of says, okay, from if it's 0 to 4,000. Kind of do it. If it's not, we throw an exception. You could write this any way you want. What's more important is that we can verify that this does things correctly, and later on verify that certain properties are upheld. So I have this test file right here. This is basically what you saw in Visual Studio. I actually just deleted the template test there.
Okay.
So I have sort of a test here that doesn't do anything right now. It says, test that 497 is, the CDX, CVII thing. So, you just write this sort of the way that you would normally write a regular test. I have my expected output, right? So that's going to be, this thing right here. And then I have my actual output. And I'm going to call Roman numerals dot Arabic to Roman, and I'll pass 497.
Okay.
And then we'll go assert dot equal expected actual. Okay.
Okay.
This is pretty straightforward. I'm going to use the terminal here and just invoke .NET Test from the test project. It's going to build it, run it, and it succeeded. That's kind of no surprise that it would succeed there, because that's what 497 is.
Sure.
But say this was like a real true library that I wanted to release out to the public, and I wanted to make sure that it was really, really good.
Right. So you'd have to test more than just 497.
Yeah, there's a lot more numbers than just the number 497.
Right.
The int in this case, this is like a signed 32-bit integer. That's a pretty big input space.
Right. You haven't memorized the max range, have you?
No. Yeah. No,
it's a lot of digits.
It's
we
a
know
lot.
that.
Yeah. So there's a couple of approaches to that. So this is what's called sort of like an oracle, test oracle. Like and the reason why I'm saying is like I know what the expected outcome is.
Right.
And so I'm just verifying that that my expected value is equal to what I actually got. And that's fine for a certain class of tests. But in this case, if I want to verify the whole input space, that's a lot of tests.
Yes.
That's in the billions. And I'm personally, it might be, yeah, I think so. I'm not interested in writing a billion unit tests. It's a little too much.
It sounds like a little too much, and it sounds like it would take a really long time to run all those unit tests, even if you could write them.
Yeah, I'd need a pretty beefy machine. And
you'd almost want to write code to generate the unit test, right?
Yeah.
So.
Well, and you could imagine, this is just a simple given an int to produce a string. It doesn't really do too much crazy stuff under the covers. You can imagine something more computationally expensive. And then if you have something that's computationally expensive and you have a massive input space, that's going to be kind of infeasible to write tests this way.
So what do we do?
So sort of the next step is what's called property-based testing. So I'm not really an expert in property-based testing, so I can only sort of give you like a layman's sort of approach to it. But sort of what I said before is, this notion of like having a test oracle and knowing what the expected output is. Well, what if I'm not really interested in the expected output being equal to the actual output, but I'm rather interested in some certain properties being upheld?
Okay.
Because there's a certain there's certain ways that Roman numerals have to be formatted. So you can't just have like arbitrary. You can't just have like an arbitrary V, X, Y, blah, blah, blah. Like that's just kind of nonsense.
Right, because VV becomes X.
Yeah, and so there's sort of some things that you could do here. So I've written some additional code. And so what I'm after here is trying to test that a few properties are upheld, rather than testing that every single input and output pair matches what I would expect.
Makes sense.
So what I've written is some code right here. I've called it Roman numeral properties. I have a really basic helper function here that just determines that instances of this right here appear a maximum number of times, and that maximum number is based off of count.
Okay.
This input value here. And then I have two properties right here. One's called has a max repetition of 1v, and the other is has max repetition of 3 x's. right? So these are now properties that, I could pass in an arbitrary number of inputs, and I can verify that that property is upheld rather than, getting the correct expected value.
Got it.
Getting the expected value.
Right.
So I also have another helper here because if you recall in the library, it was sort of expecting from 0 to 4,000. So I just have a little what's called a filter because what's going to go on is I'm going to use the library FSCheck, and FSCheck is going to do input generation for me.
Okay.
But I want to make sure that the inputs that it generate are correct, for the range. Are within the correct range for what can actually be passed into the library, because this could give a whole bunch of negative numbers, and I'm not interested in verifying negative numbers.
Right.
I'm like that I could do with Oracle-based testing, but I'm interested in verifying, okay, for the stuff that's actually part of the valid set, do I get the correct output? And so in this case, there are two tests right here, and I'm going to just sort of walk through that. So this one is tests that Roman numerals have no more than one V inside of them. I'm calling this a verifiable property here. So I'm actually creating another function inside of this test function.
Okay.
Okay, I just call it prop. Prop, given an int, produces a bool. If you look at this, the signature right here, given a value produces true or false.
Okay.
So what I'm doing is I'm actually calling the Arabic to Roman function. Right, I'm actually calling this in this function with a given number, and that number is going to be generated by the library, so I'm not actually writing it myself.
Okay.
And then I'm going to take that output, and I'm going to pipe that output into this specific Roman numeral property, right? So in this case, it takes in this string called Roman, and then it actually verifies that maximum repetition property. So there's sort of this chain of function calls where a quick check is going to generate some values. Those values are then going to go into a function. That function is then going to go into this other function, and this function is going to do the actual property enforcement there. So that's just sort of the basics of function composition and functional programming that all just kind of flows together.
Flows in, yeah.
When you do this. So, and again, I have these backticks right here. You could name things anything you want, really. I just called this thing prop. You can call it whatever you want. And then I'm going to pass it into this method here called quick. And quick, I'm just going to verify that okay, I'm going to this test with range function right here, this acts as the filter that I mentioned before. I'm just going to make sure that the input values fall within the correct range that I've defined in my filter. And this takes in an input function f, right? So it actually goes ahead and it runs that function if the input value falls within the correct range.
Okay.
And so that function f is this property function right here, right? So what's going to happen is this will actually be verifiable. This will actually be, as per the parameters that I have set, it will say, this property is upheld for the numbers that we're generating and passing into the function. But you may also be interested in properties that are not going to necessarily be correct, right? What are called falsifiable ones.
Okay.
So this is sort of like, expected failures, and understanding how those expected failures can come to be. So in this case, this property have no more than 2 x's is sort of the opposite. Rather than having a property that we know is going to always work, like it's always going to be upheld, we want to have a property that we think might actually not be upheld. And so then if it's not upheld, we can diagnose and sort of figure out what's going on from there.
Okay.
And this is a lot more efficient than if I were to just write a billion tests and see which ones passed or
and
failed.
throw out the failures.
Yeah.
Right.
And so in this case, I've defined another property. I've done it by composing this max repetition property here, and I've had this x, and I've said, okay, 2, no more than 2. That's the upper bound that I want to have.
Okay.
And Roman, this is the string, and I'm just going to go ahead and pass that property. I'm going to have my actual property function right here. Again, taking a number as input, that's going to be generated by the by the FSCheck library. It's going to go ahead and generate a value. It's going to pass it into this property right here, and we're just going to kind of see what the results are.
Sounds like a plan.
So I'll just call Donna test here. It's going to take slightly longer just because there's some
iterating through the ranges and
exactly. So what we have right here, it says that they all pass. There's some additional members that you can have where you can say if it fails the check, actually fail the test or throw an exception or something like that. I'm just going with this really basic one here. So we didn't get any message about this.
Right.
So that means we can say that this property is being upheld.
Okay.
But in this case, we actually did get a message right here, falsifiable after 21 tests. So what happened is after the 21st input that it generated, that property was no longer upheld. So we're actually trying to verify it with 100 tests, right? And I could tweak that to be 1,000, I could tweak it to 1,000,000, sort of anything like that. But already at 21 tests, it failed.
Okay.
So now I can know, okay, this library that I have right here is not upholding that property. Right? What was that property again? That was test that Roman numerals have no more than 2 x's. Well, there's a bug in this code. And so because of that, I can now try to figure out what's going on there. So sort of the flow that you would have is you would say, okay, there's a bug in this code, this property is not being upheld. Let's start writing some Oracle-based tests and seeing specific successes and failures and see if we can hone in on that. Or if we happen to be really, really smart, which I'm not, we could actually fix the bug in line and then run this again. So it's sort of like a smoke test in a way, because you're just kind of like, okay, just throw a crap ton of values at it and see what happens.
But it's going to take you right to the exception, so you're not having to do brute force across the whole line of integers, which would be insane.
Yeah.
Right.
Yeah. And so one last thing that I wanted to show here is the actual project file, because project files are how you specify your dependencies and stuff in .NET Core, and there's nothing crazy going on here at all. The only thing that I have here is I just have this FSCheck library. I think I installed the alpha. You can do whatever. It's just a package reference. Works on any .NET. You can actually do this in C# if you'd like.
Right.
But it's cool in F#, so that's what I'm doing. and yeah, this is just a normal test project. I just newed this up with .NET New. In fact, I could. Whoa, that's not what I was interested in. There we go. All right, there's a whole bunch of templates here. I installed a whole bunch, but if you look under the unit tests, these same unit test projects, these are the ones that you saw in Visual Studio. They show up here, on my Mac with .NET Core.
Right.
Yeah. So you can just go from there, create whichever one you want. Just go ahead and add this package, this FSCheck package, and then you can have sort of that two-pronged approach to these sorts of problems, where you have your, I guess what I'll call normal tests, what most people typically write, and then you can have sort of these. Okay, I can't define Oracle-based tests off of my entire input space. So I'm going to have this screen to see, if these properties are upheld, and if they're not, I'll dive in and sort of go from there. And so there's a whole lot more that you can do with F# and unit testing. There's actually some other libraries that I haven't covered that have some other interesting ways that they deal with failures and sort of the composition of tests and dealing with whole suites of tests and knowing how to execute some versus others based off of other properties. And there's a whole suite of things that you can do with FSCheck that you can have some really intelligent property generation and some really cool filtering and things like that. But it's quite powerful. Even just some basic stuff like this, it doesn't take very long to throw together, and you can be pretty productive and just sort of do whatever you need to do.
And then as a C# developer, I can say I'm using F#. I'm pulling in FSCheck.
Yeah.
Not entirely true, but
well, so another thing that I'll just point this out. I'll get rid of a little bit of white space. One of the reasons why F# is great for testing in general is testing is like there's a few people out there who really love it, but most people aren't that in love with testing. It's kind of like a chore that they got to do, and they know that it's important, and it's like flossing, right? Not everybody likes to floss, even though we all know that that's. Dentists are really happy when people don't floss because that's how they make their money.
Right.
And so using F# for tests, even if C# is what you have for like your whole system, there's just a lot less code you got to write to get stuff done.
Okay.
I've got like right here, including comments and whitespace, 47 lines of code. I have an Oracle-based test for a library, and then I have some properties, and I have 2 property-based tests here that verify some rather interesting properties. If you know how to write good C#, it's not going to be a tremendous amount of code either, but I would challenge most C# programmers to do this sort of stuff in as little lines of code as you can do it here.
I think there's an ulterior motive here. I think someone's going to learn a little bit of F# to write some tests, get hooked with the language, and you're looking to draw them over to full-blown F# developers. This is definitely something I want to look into more. But I love the fact that not only is it completely integrated, same familiar testing harness that we have in Visual Studio, but that we've got full-blown Visual Studio code support. Now, I've used a lot of code extensions. It's pretty cool to see an extension that does so much, actually creates that entire environment right there in code.
Oh yeah, this extension is pretty incredible, the Ionide extension. Even if you're not interested in F#, I recommend just downloading it so you could just be in awe of like
oh, look what they do over there.
Yeah, well, I mean, it totally transforms VS Code into a fully fledged IDE. And so there's a lot of F# developers actually that, I guess I would say they would not normally have been our users because traditionally F# has sort of existed inside of Visual Studio.
Right.
And they've been non-Windows users. They were like, Windows is cool, VS is cool, not for me.
Right.
But now they have an option, and so they can say, oh, I'm really interested in the language, but I don't have to use it in a particular environment. I can use it in the environment that I prefer.
Right, and you've got all the tools to support everything you'd want to do with that development lifecycle.
Yeah, exactly.
Wow, this has been a lot of fun. Thank you so much for coming out with your broken arm and sharing the information. I'm intrigued by FSCheck. I think it's a cool library. I'm going to check that out. This has been F# testing on .NET.